Using a 3x4 matrix, I'm going to show that you can do elementary row operations by matrix multiplication. The first one is to multiply a row by a non-zero scalar. So basically, you want to take this matrix, you want to take a matrix, multiply it by the matrix that you want to rotate or interchange to multiply a row by a scalar, and you want to get that result. Suppose we want to multiply row 2 by 4. So we want to still have A11, A12. The first row does not change, but the second row does. Each entry gets multiplied by 4. Each entry gets multiplied by 4. The third row does not change. Now, generally, you modify an identity matrix. So I start off with the 3x3 identity matrix. Because since this is 3x4, the size over here has to have a 4. And since you want it to be a square matrix, it has to be a 3. These have to be the same. So it's 3x3. That's how I knew to put a 3x3. Alternatively, you could have said, you know what? I need to multiply this row by that column. I have to dot it. So they have to have the same number of entries. Now, if you want to multiply the second row by any scalar, say 4, just change the 1 to a 4. Now, when you multiply this row or dot this row by this matrix, you're going to get back the first row. It's not going to change. When you multiply the third row by each of these, you're going to get back the last row. You're going to get this back. But you know what? When you multiply the second row, which I'm going to put its answer in the second row, when you multiply the second row by each of these columns, 0 times A11 is 0, 4 times A31 is 0, but 4 times A21 is 4 times A21. And then when you multiply 0 by the second column and 4 by the second column, second entry, the 0 by the third, all you're going to end up with is 4 times A22. Just what we wanted. And last column, third column. When you multiply 0 times A11, that's 0. Multiply the 0 times A33, that's 0. Add the zeros, get 0. Then add on 4 times A23. And that's just what you get. 4 times A23. Same game with the last column. You get 0 times this, you get 0 times that, and then you get 4 times A24, which is 4 times A24. So all you do is you change the 1 in the row that you want to change. You change the 1 in the row that you want to change to the multiple you want to change it to. That is how you interchange, that is how you multiply one row by a scalar. Now, the next thing is suppose we want to interchange two rows. Maybe row 2 and 3. So we have their beginning matrix. We want to multiply it by something, and what we want to get back is, well, we don't want row 1 to change, but you want row 3 to now be in row 2 position. A3, 3, A3, 4, and row 2 to now suddenly be in row 3 position. So again, you modify the identity matrix. So let's actually write it down. Now, row 1 did not change at all. This row, it's right there. It didn't change. So I'm going to safeguard this, because when I dot this row with each of these columns, I'm going to get back just what I want. Now, you know what? Something interesting happens. When I multiply or dot that row with each of the columns, with each of the 4 columns, you know what? I get back row 2. And I do want to get back row 2 with no changes. I just want it to be in the 3rd row. And if I multiply, if I dot this row, rows 3, with each of these columns, you know what? I get, and when I say columns, I mean all of these. I get back this. But wait a minute, that's exactly what I want to get back, except I want it to be in the 2nd row. Okay, so since I wrote on this a bit, let's get rid of it. We'll put it back. One zero 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 1 0 0 0 1. Like I spoke about before, we're not going to change the 1st row. In the 2nd row, when I multiply this 2nd row by this matrix, I get back what I want. It's just in the wrong place. And when I multiply this row by this matrix, I get back what I want, but in the wrong place. Why don't I just interchange those 2 rows? How about I put 0 0 1 and 0 1 0? That is how you can interchange row 2 and 3. Just go to the identity matrix. Just go to the identity matrix. That's a 1. And if you want to change row 2 and 3 on this matrix, just interchange row 2 and 3 on the identity matrix. And there it is. 1, 2, 3. So you multiply by this if you want to interchange row 2 and 3. Now, there's one more elementary row operation. You want to add a non-zero multiple of one row to another row. So in other words, maybe you want row 2 to become a multiple of row 1, but add on row 2. I just took row 2 and I added on a multiple of row 1. So what exactly does that mean? So I'm going to have some matrix here. I'm going to multiply it by this, and row 2 is going to become 3 times row 1, 3 times this, plus that. At least the first column will be that. 3 times this value, 3 times A12 plus A22. And let's put this up here. And then I'm going to do, oops, not plus. Then I'm going to do 3 times that plus A23. And then 3 times A14, I'm going to add that to it. That is going to become the new row 2. And row 1 and rows 3 do not change. A31, A32, A33, and A34. That's what we want to get. Now, if I put down just the identity matrix, I'll get everything in row 1 correct. I'll get everything in rows 3. And I'll also get these entries for row 2. I just want to pick up this 3 times the row 1. So I'm going to go to row 2, and I'm going to put a 3 in column 1. Now, when I multiply this by that row, notice I get 3 times that column. I get 3 times A11 plus A21 plus nothing. Second column, I'm going to get 3 times A12, just what I wanted, plus A22. Get that entry, A22, plus 0 times A32. That doesn't give anything. And then 3 times A13 plus 1 times A23 plus 0 times A33. And then finally, 3 times A14 plus A24 plus 0 times A34. I'm getting back exactly what I want. And what you need to do is you have the identity matrix, and I want to change row 2. I want to change row 2 and I want it to affect the first row. So I go to the first entry in row 2 and I put my scalar. I want to multiply by 3. Okay, and there it is. There, this here is the matrix that would add, it will keep row 1 the same, it'll keep row 3 the same, and then it would add on 3 times row 1 to row 2. And with this type of logic, you could do this to any size matrix. And if you think about it, each of these matrices can have an inverse. They can be undone. Think about why that can be. Think about how if you multiply row 2 entries by 4, you can undo that. Think about how if you interchange row 2 and 3, how you can undo that. Those two are pretty simple. The matrix that will undo this will be 1, 0, 0, 0, 1 quarter. It'll divide divide row 2 by 4 or multiply each entry in row 2 by a quarter. And this should be a 1, I apologize. If you want to, so we interchange row 2 and 3. Well, if you want to get back to where you started from, interchange row 2 and 3. And this is the matrix that does that. If you want to undo adding 3 times row 1 to row 3, you know what you do? Take away 3 times row 1 and add that to row 2. So all of these have inverses, which is very important. Okay, this finishes this video. Hope you enjoyed it. If you like to see videos like this, please subscribe to my channel, leave a comment, and as always, come back and watch and learn.